In this video, I introduce a cross-modality representation learning from a transformer. LEXMERT learns vision and language multimodal representations and the alignment and the relationships between visual and language modalities. LEXMERT consists of three encoders. First one is an object relationship encoder. Second one is a language encoder, and the third one is a cross-modality encoder, as shown here. This object relationship encoder, this language encoder, and this cross-modality encoder. This is a vision input, and this language input. First, we use CNN maps input to ROI features FG and the position features PG. Maps language input to word embedding and index embedding. And then we use FG, PG to get F caret G and P caret G. And then we get the input to the object relationship encoder. Similarly, we use WI and I to get WI caret and UI caret to calculate the input to the language encoder. Attention layer first calculates the matching score AG between the query X and each context YG. Score and normalized score are defined as AG and alpha G, as shown in this figure. The output of attention layer is a weighted sum of context vectors with respect to the softmax normalized score, as defined here. A self-attention uses the query X is in the set of context YG. A language encoder and object relationship encoder follows the input embedding layer. Each encoder is a self-attention transformer that focuses on one modality. The feed-forward layer is to further track the relationship between elements in a single modality. Residual blocks are used to reduce the gradient vanishing in backpropagation, as shown here. This residual block, residual block, residual block. This is self-attention, and this feed-forward layer. Two cross-attention layers learn vision from language and learn language from vision. The outputs of two self-attention transformers are computed by using these two formulations. The self-attention layers are applied to output of the cross-attention layers, as shown here and in this figure. And FF layers are applied to outputs of the self-attention layers to predict the final output, as shown here. LEXMERT has three outputs for language, vision, and cross-modality. The language and vision outputs are the feature sequences generated by cross-modality encoder. The cross-modality output is a special token to indicate if the language and the vision match each other. LEXMERT randomly masks the input words with a probability of 0.15 and then predicts the masked words from the context in the language modality and vision modality as well, as shown here. LEXMERT pre-trains vision by randomly masking objects with the probability of 0.15 and predicts the properties of these masked objects. LEXMERT can infer the masked objects either from visible objects or from the language modality. Therefore, LEXMERT performs two subtasks. ROI feature regression regresses the object ROI feature FG with L2 loss, and the detected label classification learns the labels of masked objects with cross entropy loss. To learn a cross-modality representation, LEXMERT is pre-trained with two tasks that explicitly need both language and vision modalities. For more details, please check with these references. Thank you. Bye.